Hello. The lesson I decided to try and discuss is what I call the artistic periodic table, and this is a activity that kind of culminates at the end of our periodic table unit, and this would be for chemistry, obviously, and grades 9 through 12 primarily. Um, about any age group in the high school could probably do this pretty easily. The lesson goals and standards. Um, Basically, when this activity is done, going along with all the other activities we've done, the students will learn about how the periodic table was organized based on the characteristics of the element. We study the history, the evolution of the periodic table, starting with Mendeleev, going on to Moseley, and then through the unit we discuss the different areas of the periodic table and why those elements have been placed there because of their similarities and their periodicity. Um, in terms of standards, this lesson in particular would go with Standard 2A Benchmark 2.2, which discusses that students should know the areas of the periodic table, should understand the relationships between the different elements and groups and periods, and how they all basically react in similar ways when they're placed correctly. Um, in the nets for students, this lesson in particular would demonstrate creativity and innovation, um, conduct research and useful information, and use technology effectively and productively. The instructional objectives for this lesson is, first of all, they need to be able to correctly identify the regions and groups of the periodic table. When they're doing their projects, they'll have to know the different areas and regions in order to do their research and to report on that. They will also research different elements using internet resources. Basically, they're going to find as much background information about an element as they can, so that they're going to be able to creatively come up with some sort of representation of that element. Okay, and so that is our final objective there, is the whole idea behind this activity is to kind of give those kids in particular that are not necessarily science oriented or math oriented students, more artistic, a way to show what they have learned and represent an element abstractly from their research. And so really what we do then is we will take each person's work and create a large artistic periodic table from it. Um, for teachers, preparation for this, obviously teaching the unit is a good start. Um, so before we really start this activity or this lesson, it's good to once again review the areas of the periodic table and discuss why elements are where they are. Um, you should also then have a presentation of this project that they're going to work on and have examples for them to look at. It's a little bit scary for kids that are not artistic at all or creative at all, and so having things for them to look at kind of eases that whole problem. Um, Also, I like to have the website ready to pull up that kind of was the inspiration for me for this project. It is a project that the American Chemical Society had commissioned some graphic artists to take different elements and do their own little research on them, and then they use their graphic art skills to abstractly represent those elements. There is no atomic numbers or no atomic symbols in their art. It's basically based on whatever research they did. Also, since the kids are going to need to use computers, depending on the school situation, you're probably going to have to request some computer usage time. You're really going to have to give them a few days to really look into this stuff, so you have time also to go around and help them find worthwhile information. some of the elements are a little obscure, so finding information on them sometimes is a little bit difficult. And so whatever they can find to kind of help them formulate some sort of idea, some sort of design is helpful. Also, you should have index cards to distribute to the students. I found out the hard way, I guess. If you don't give the students the index cards, you tend to get a lot of different sizes. So if your idea, or at least my idea has always been, once the artwork is done, we put it up on the wall and create a periodic table. If the cards are all different sizes, that doesn't work very well. So I highly suggest have whatever size of index card. I usually use a 4x6, but have those ready to distribute to the students, and that way you can make sure that everything fits together. Student active participation. Basically, in this activity, in this lesson, students will research the information for the assigned elements. I don't let them pick, because if I do, I'll get 5 or 6 or 12 or 50 oxygen cards. So what I do is I take a periodic table and I cut it up and I just randomly assign them. From there, the students themselves have to come up with some sort of abstract design. Again, they cannot have elemental symbols or elemental atomic numbers or anything like that to represent the elements. Whatever they come up with has to be something that has to do with the background that they found. The students then will also present their designs to the class. So they have to actively have a small presentation ready to go. Adaptations for learning disabled, I have had a few instances where doing 2-3 cards is probably a little much, and the actual drawing and everything. So you can do it a variety of ways. Probably the way I've done it the most often is, instead I've asked the paras to help the students create maybe more of a poster where they cut and paste photos that go along with the uses and the origins of their elements. That's usually the best way I've found it seems to work, and they can present that a little bit, or just at least post it. Gifted, there's a lot of different things you can do. Assign more cards, expect more expectations from them. Another thing you could do as well is have your gifted students kind of come up with this idea where they create a periodic table of their own based on other materials or other subjects. For example, tools for that you would use in fixing a car or whatever. Maybe they make some sort of hierarchy of a periodic table of tools or M&Ms or whatever they think of. It's kind of the sky's the limit on that. Assessment for this, what I like to do with this, it's kind of subjective because it's kind of what I like, and what I think of it, but I do have a rubric, and here's a picture of that rubric. I don't know if you're able to read it very well, but you can see I basically just have a scale of 1 to 4 for completing the assignment, presentation, of the card itself, how it looks, how original it was. If they're doing potassium and they just draw a banana on it, that's not very original. So they get a little bit downgraded on that. Part of the research grade then is on the back. They're going to write certain things that I'm looking for. How much of that did they do, or did they just go for the bare minimum? And then in the end, artistic appeal. When I look at it, as you can see, if it's really good, it made me sing a little song, they get a pretty good grade. If it made me queasy, then obviously they didn't spend enough time on it. So what I also have here then is just kind of the example I show the kids. I'll go through this quickly. This is the purpose, design abstract representation. I tell them that they're going to do 3 index cards. They'll be assigned randomly, graded on the information about the element as well as their creativity. Again, I stress that there's no elemental symbols that should be obvious. If they can come up with a way to abstractly have those involved, and I've had kids do that with Photoshop and Exact, those kind of things, and that's okay. The back of the card, I kind of lay it out in just a real brief statement what they should have, so they have a good idea. Now this is kind of the bare minimum they should have, but the most important part of this is not only they do the background information, but The part I'm really interested in is the explanation of the design, what they were thinking and why they did what they did. And when I look at a card, I like to be able, or I like to have to look at the back in order to tell what it was all about. From here, also just goes on, it's where your picture will be on the front side, and it just discusses, you can read through that. No symbols, once again, very abstract. Basically, they can do any kind of thing they want. They can draw it, paint it, use collage. You know, if they can't draw like me, they have to cut things out, Photoshop, whatever they want. Creativity is the main thing. I want kids to think outside the box and express themselves and express their elements. So then I show them a couple pictures of the original things that I looked at. If you look at the one with the American flag, if you look closely, that's actually a smoke detector because that's Americium. The element is used in smoke detectors, and so that artist did that. Up in 97 is berkelium, so they got the whole tie-dye thing. If you look at number 1, that's hydrogen, obviously. Hydrogen is a big part of water, so it kind of has a water background. And these are some examples of things that students have done in my class. Um, Very good drawings. This person here collaged it. Over here in the bottom right corner is R. It says ARG, like a pirate, and then the switch is on. So actually that was argon. The dentist person, the element they used, probably can't see it, but he photoshopped it very slightly. I never noticed it till he pointed it out, the actual name of that element. But after they present and everything, we hang these up, and they really enjoy seeing their different types of work. Thank you for taking a look.